Hi guys, this is me, Bojack Human. Today I'm gonna explain hiring workers from today's Codechef November cook-off. So in this problem, if you have already read the question, you will know like they have given some fancy words of saying you have k numbers. Okay, okay. The number will be k numbers and their LCM is given. Okay, the LCM is x. Now you have to choose these k numbers in a way that the summation of these k numbers are as minimum as possible. Okay, suppose you are given 6. Okay, 6 is the LCM. Then you have to, and the numbers are given, k is given 2, so you have to choose two numbers whose sum is minimum and their LCM is 6. That is the question. Okay, so like it's not the exact question, but if you read the prompt then sum it in short, it becomes this question ultimately. So how we can do that? Okay, like suppose the given x will prime factorize that number. Okay, like suppose the given number is 180. Okay, if we prime factorize it, we get 2 into 2 into 3 into 3 into 5. Okay, that's what you get. Now suppose the team is given 5. Okay, I'll have to choose 5 numbers in a way so that their LCM is 180. What you can do? Okay, we can take these two 2's together, these two 3's together, and this 1 5. Okay, now it's become 4 9 and 5. Okay, if we choose in any other way, like suppose you are saying like why can't I take these 3 and into it with this 4, then it becomes 12 and I have 3 and 5, that summation will be small. But if you take these 3 from this hold and added it to this hold, then this number will have a 3 in it, and this number also has a 3 in it. Okay, now they have a common prime in between them, so they both will be cancelled out. Okay, so the ultimate LCM will not be 180. Okay, if you do in any other way, so like suppose, so we can say if x is given and the prime factors are p1 to the power n1 into p2 to the power n2. Okay, dot 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 p right to the power n right. Okay, now if I took any p1 from this hold and take it to the some other hold, then these two blocks will have a common prime in them. Okay, so the ultimate LCM will not be x, so we have to take the primes separately so that the GCD is 1 and the ultimate LCM becomes the number x given in the question. So if we are given like suppose 60 54, then 2 into 27. Okay, we take these two numbers separately. Now their LCM is 54. Okay, suppose we were given 210. Okay, then the prime factorization will be 2 into 5 into 3 into 7. We take all of them separately. Okay, now if we are given, like, we have to choose 6 numbers so that their LCM is 210. Okay, we can just add the additional number as 1. Okay, then the LCM remains 210 and the summation is minimum. Okay, like for this, if we're given 3, like we just have to take 1. Okay, like in this question, if we're given to choose 5 numbers, we just take these 3 numbers, then add 1 and 1. Okay, then the summation, the summation of the k numbers will be 4 plus 9 plus 5 plus 1 plus 1. Okay, that if it is greater than the unique prime numbers given in X. What if it is smaller? Like suppose what if it was given 210 and we have to choose 2 teams. Okay, now the number is 2, 3, 5, 7. So in today's contest, I was trying to solve them greedily. I was taking the smallest 2 numbers, multiplying them, then chucking it back to a priority queue. Then again, like if I multiply them 6, 5, 7, then again I took the smallest 2 numbers and multiply them and chuck it back to the priority queue, so it becomes 30 into 7. So my end results become 30 plus 7. But if we think about it, the optimal solution will be if I take 2 with 7. Okay, then it becomes 14, and 3 with 5, then it becomes 15. So here comes another observation. The number x will be up to 10 to the power 6. So if you multiply the first 7 prime numbers, sorry, 2, 3, 5, 7, 11, 13, 17, it goes beyond the limit. Okay, so the unique number in this unique prime number in this x will be up to 7. Okay, so if k is smaller than that, okay, so k has to be smaller than 7. Then in these 7 numbers we can write a brute force and see in which way we get the minimum. So like if we are given 2, 3, 5, 7, we can just brute force it, like see every partition and see which partition gives us the optimal solution. This optimal solution will be 29. Okay, so that's how you solve this problem. So in recap, if k is smaller than the unique prime numbers in X, then we do a brute force to find the minimum, because the count of the unique prime numbers will be up to 7. If k is greater than the unique prime numbers in X, then we can just take those prime numbers with their power and make the additional ones 1. So this will give us the summation, the optimal summation and the optimal answer. So let us take you guys to the code. So here we can see, like I do a prime factorization here. Okay, temp1, I push back to a vector, just simple prime factorization. After prime factorization it, I check if the size is greater or equal to k. If size is greater or equal to k, I call some partition to find the smallest sum and then output it. If k is greater than size, then I take the sum and see what's the extra remaining part, and I take them as 1, so I add it to sum and print the sum. Like how do I do the brute force? You can do partition dp, but what I did here was write a backtracking solution. Like I did every partition, like I took a for loop, okay, the given vector, I did a for loop in it, okay, choose two indices I and j, okay, choose two indices I and j, multiply them together and push them into a new vector. Okay, now do another loop over the previous vector and see and chuck them into the new vector. Okay, so in a way we are erasing v1, vi and vj, replacing it with their multiplication. Now we are calling the partition and chucking one out from left, okay, and calling it again. Then it goes, when it keeps on going, when left is equal to 0. Suppose what I send as left is, like suppose I was given 7, the size was 7 and my the number of team I had to choose was 4, so I give left as 3. Okay, so like first it takes away 1, then it takes away 2, then when left is 0, that means the 7 has come down to 4. So when left is 0, I just checked what is the summation, of the vector and choose the minimum about all partitions. So suppose we run it. Suppose we want to see all the summations. It will give us all the summation of the ways we can do. Okay, so this is the problem and this is the solution. I guess you guys liked it. Like, I was so close of solving this problem. I thought there was a greedy way of minimizing it. I didn't understand the upper cap was 7. Like, you can run a brute force and get a accepted. It was a good problem. I really like this problem, to be honest. Okay, that's it for you guys. Goodbye, have a good life, see you again.